Two men are pulling on ropes attached around the neck of a mule that does not want to move. One man pulls with a force of 55 pounds, so we'll have his force be at some angle of 55 pounds. And the other pulls with a force of 75 pounds. And so that's the magnitude of that vector. The angle between the ropes is 25 degrees. And we want to know how much force the mule must use in order to stay put. Assume the mule knows the proper direction to apply the force. So if we add these two forces together, then the mule essentially needs a force equivalent to the resultant. It would be pulling in the other direction, but the strength of it essentially, or the length of that vector, that would need to be the magnitude of that force. So that would be what the mule needs. So as we look at this to see kind of what information we know, we've got two sides of a triangle, 75 and 55, but we don't have the angle between them, although we know this angle is 25, so that leads me to this angle to be 155, because when you have two parallel lines and you have a line here, these two angles are supplementary. They need to add up to 180. And so if this one's 25, then this one needs to be 155. I can now use the law of cosines then, and so the magnitude of the mule needs to equal the sum of the squares of the other two sides, which are the other two forces magnitudes, minus 2 times the product of those two sides, times the cosine of the angle between those two sides. All right, so now I can take, now this, I did one thing wrong. I needed to put the squared on there. It's the magnitude squared. So if I want the magnitude, I can get that if I take the square root of all of this. So the magnitude the mule needs to pull is going to be the square root of this, which when we put that in the calculator, we're going to round to the nearest pound, and that would be 127 pounds.